Greetings, class, and welcome to the section of operations management, where we do aggregate planning and sales and operations planning. The key component to planning itself is the planning process. The planning process begins with the top executives, stemming down to the operations managers, which is the mid-level section, and then the operations itself, which is done by the foremans, managers, etc., and that is the third tier at the bottom. That doesn't mean that it's because it's at the bottom, it's less important. In fact, those are the key component and most important factors that we look at in the planning process itself from the viewpoint of operations management. From the strategic portion of it, the top executives are the ones that create the long-range plans that are approximately 1 year out. Sometimes they could be a little bit more. In my organization, we normally stem out to 18 months, but we do have a long range plan, which stems out to be 7 years for that. But normally long range plans are 1 to 1.5 years. But if you have capital improvements that you want to make in the long term, then you go into long ranger plans, which is like 7. Issues to look at from the top executive in the planning process is research in itself, and of course the development of what you're trying to do to change the format of the process itself. New product plans that you want to develop, capital improvements, like I just mentioned. The thing with capital improvements is that for you to obtain the capital in itself, it takes time. So you develop a plan. You forecast it out as to when you want to implement that capital plan, and if it's large enough, that's why in my organization we take 7-year planning process, because it takes quite a lot of capital in order for it to be implemented, and we have to look for the capital. Then we also have facility location and expansions. So we're constantly, that is part of the 7-year program. That's the reason for the long term. Now in the middle section, we have the operations managers with sales and operations planning teams. Here, this is where the intermediate range plans come into play, and these are anywhere between 3 to 18 months. The issues that they're concerned with are sales and operations planning, production planning and budgeting, setting employment levels, inventory, and subcontracting levels. Additionally, they analyze operating plans. And then at the operations managers, the supervisors, and the foremen, we have short-term plans, short-term range plans, which are about now, 1 week, 2 weeks to 3 months. And these are usually for scheduling purposes, etc. But they all have to be aligned with the intermediate plan and the intermediate plan with the long-range plan. Now, some of the concerns that we deal with in operations management at the supervisory and foreman level include job assignments, ordering, the ordering of stocks, or ordering of material, job scheduling, dispatching, overtime concerns, and part-time help, if any. When we look at sales and operations planning, we look at coordination of demand forecasts with functional areas and a supply chain. So one of the biggest errors that we make when we do forecasting is that we try to back into what we need. And this is predominantly one of the pitfalls of budgeting. Right? If you have a great budgeting supervisor, budgeting manager, VP or whatever, that's not what this person does. What this person does is calls it like it is. This is what we have. This is our future forecast based on either linear programming, which we'll discuss a little bit further on in this discussion itself. Probabilities, probabilistic or stochastic modeling, which we'll also touch upon there. And you'll see things like, and I'm sure when you study, some type of modeling techniques like the Monte Carlo approach and stuff, that's the one I normally use, the Monte Carlo approach. I try to use 20,000 iterations because the computer allows me to do that within an hour. So we've come a long way with computing power, so let's use it. So these are the aspects of forecasting, and you don't back it in. When you look at sales, you try to actually program forward based on past sales, and then what does the economy look like? Again, there is no crystal ball. but we do have analytical systems that we can use in order to project the future. Typically done, the sales and operating planning is typically done by cross-functional teams. Finance gets involved, budgeting gets involved, the actual developers of the whatever you're doing, whether it's sales, the sales or the building of the object that you're selling, etc. Determine which plans are feasible, and you give those weights. You limit, all right? Your limits must be reflected. So if you don't have enough capacity to fill the expected or the forecasted lots, then it's a mute issue. You have to either improve capacity, and then you got to figure out whether or not finance and budgeting align itself so that we can have a good protocol of forecasting sales and production manufacturing. It provides warning when resources do not match expectations, and the output in all of this is the aggregate plan itself. Now, decisions must be tied to the strategic planning, as I just previously mentioned here, and integrated with all areas of the firm over all planning horizons. Bottom line, this is an integrated planning process. This cannot be stovepiped. Now, sales and operations planning is aimed at the coordination and integration of the internal and external resources that are needed for a successful aggregate plan. Communication of that plan to those charged with its execution is important for it to be fully employed and developed. It requires a logical unit for measuring sales and output. Hence, it has to be quantifiable. It can't be qualitative in nature. You have to get the quantitative people to do the analysis here. And by the way, you are the quantitative people. When you begin that process doing this. A forecasted demand for a reasonable intermediate planning period in aggregate terms, and then a method to determine the relevant costs associated with it. A model that combines forecast and costs so scheduling decisions can be made for the planning period. Remember, your break-even point is your variable costs with your fixed costs. So costs are an important aspect of determining your sales and operations planning. It also helps you in determining price. I've had many people come up and do a price determination based on a gut. Then I asked them to go back and do research and provide statistical analysis of where the pricing should be. What are the variables plus the variable cost plus the fixed cost? At least that gives us a starting point. And then from there, what are other companies with similar stuff that we provide or stuff that we sell it at? Then what will the market hold? And is our product of higher quality than the others so we can have a premium price, or is it the same and then we have to do a price battle? Aggregate planning, the objective for this aggregate planning is usually to meet forecast demand while minimizing cost over a planning period. Now, it combines, aggregate planning that is, combines appropriate resources into general terms. It's part of a larger production planning system. Now, there is a concept known as disaggregation, which means it breaks the plan down to greater detail, and it results in a master production schedule. Now, it should be, you should understand that should inventory, some of the things you have to pay attention to, and of course, ask these questions for you to develop the planning strategies for the aggregate side of the house. Should inventories be used to absorb changes in demand? Just remember, if you keep inventory, there's an inventory holding cost. There's a balance here. Should charges be accommodated by varying size of the workforce? We're going to go into that because varying size of the workforce also means that there is a learning curve involved. There's going to be the HR factor of employees that are dissatisfied, and on and on and on. Should part-timers be used, or should overtime or idle time absorb fluctuation? Again, those are inherent, those are costs. Should subcontractors be used and maintain a stable workforce? Just remember, the subcontractors do not own your business. Consequently, they do not have that much of an inherent desire per se of making your business ultra successful. You are. Right? But there's some times where subcontractors are important and we need to go ahead and use them. Should prices or other factors be changed to influence demand? Well, we just got through talking about it. You have to figure out whether you can or cannot. And if you can, do you want to go into a price war? Sometimes you have to. Now, let us look at some aggregate planning options. First option is changing inventory levels. The advantages to this is changes in the human resources are gradual at this point, or possibly not even. There's no abrupt production changes in this strategy. The disadvantages, though, are inventory holding costs may increase and shortages may result in loss of sales. Some comments I'd like to make on this is that it applies mainly to production, not service or operations. There is varying workforce size by hiring or layoffs. The advantage of this, it avoids the cost of other alternatives. And the disadvantages, though, is that hiring, layoffs, and training costs may be significant. This particular option is used when size of labor pool is very large and it's easy to use. Another option would be varying production rates through overtime or idle time. The advantages to this is it matches seasonal fluctuations without hiring, training costs, hiring or having training costs added to it. The disadvantages for this are overtime premiums, tired workers, and may not meet demand. Now, we should note that this particular option allows flexibility within the aggregate plan, so it's not that bad. Then we have the option of subcontracting, which is previously talked about. It permits flexibility and smoothing of the firm's output. The disadvantage, though, is loss of quality control. You don't control it. They do. Reduced profits, because you have to pay them a premium, and loss of future business. This particular option applies mainly in production settings. Another option is using part-time workers. The advantage to this is that it's less costly and more flexible than full-time workers. The disadvantage is that you have high turnover training costs and quality suffers. Scheduling is difficult. This type of option is good for unskilled jobs in the areas with large temporary labor pool. I'll give you an example. When I was working for the city of Miami as their human resources person, we used to hire approximately 250 lifeguards for 4 months during the summer seasons. It's part-time workers, and we would use them all those individuals knew that there would be a lifeguard opening between the times of May, when we do some training and follow-up, June, when they're active, July, and August. All right. So those 4 months, we would have them. Then, of course, they would be let go at the end of August, and then the full-time lifeguards would just keep certain pools open, not all of them. So this was a plan that was, developed, strategic plan, and it's also an operational plan. It's an aggregate plan for lifeguards itself. Proved to be very, very beneficial. Another option is influencing demand. The advantage of influencing demand is that we try to use excess capacity and, of course, provide discounts to draw new customers. So we provide discounts and new customers will come to us. The disadvantages are its uncertainty in the demand. We don't know. And it's hard to match demand to supply exactly. This particular option is used to create marketing ideas, overbooking used in some businesses. Now, when you look at back ordering as an option, and this is during high demand periods, the advantages of this is it may avoid overtime. It keeps capacity constant. Now, on the other hand, the disadvantage to this is the customers must be willing to wait. But remember, goodwill is lost. So, unless, of course, you're waiting for a Rolls Royce, that's different. Your waiting period for a Rolls Royce could be anywhere between 1 year to 2 years. It's made by hand. Not many people can have it, and the customer base already knows that it's going to have that person's going to wait. unless you get it secondary Rolls-Royce. Then those are depending on market price and market availability. The comments, though, is many companies back order, right? So it's not something new. Counter-seasonal product and service mixing is another option, and the advantage to this is fully utilizing resources and allowing a stable workforce. The disadvantage is that it may require skills or equipment outside the firm's areas of expertise. This type of option is, we find that it's risky finding products or services with opposite demand patterns. So are these the options itself? Can we mix and match? Yes, you can, of course. Mixing options to develop a plan is definitely a good thing sometimes. It all depends on what you're trying to achieve, what your strategic plan is, and what you have at the what your operational plan is at current state. A mixed strategy may be the best way to achieve minimum costs. There are many possible mixed strategies. Finding the optimal plan is not always possible, but you have to try. Let us look at some strategies. The chase strategy. Chase spelled capital C-H-A-S-E. It matches output rates to demand forecasts for each period. You have varying workforce levels or varying production rates. It's favored by many service organizations. The level strategy is daily production is uniform, hence the term level. Use inventory or idle time as buffer. Stable production leads to better quality and productivity. Some combination of capacity option, a mixed strategy, might be the best solution for this. The graphical method is a popular technique. Easy to understand and use. It's trial and error approach that do not guarantee an optimal solution. It requires only limited computations. The graphical methods determine the demand for each period, the capacity for regular time, overtime, and subcontracting each cost. It finds labor cost, hiring and layout costs, and inventory holding costs. Remember I told you that it's good to go ahead and look at all the cost factors to be able to do the pricing strategy correctly. Consider company policy on workers and stock levels, and develop alternative plans and examine their total costs. Now, we do have some mathematical approaches to this. It is useful for generating some strategies. For example, for transportation purposes, sometimes we use in the transportation method linear programming. It produces an optimal plan, works well for inventories, overtime, and subcontracting, does not work when non-linear or negative factors are introduced. Now, most people gloss over that last statement that I just made. Let me repeat. The transportation model of linear programming does not work. In fact, any linear programming does not work when non-linear or negative factors are introduced. What does this mean? What it means is that the external environment is fluid, constantly changing. So for basic programming itself, linear programming works, but it's not 100% foolproof. Here's where probabilistics takes into play. So you have to add a probability to this to see what is the probability of the answer from the linear programming actually coming to fruition. So linear programming, effective, it's very simplistic, good math, but it's not 100% foolproof. But it does work for what you need, for quick answers that you need. Other models include general form of linear programming and, of course, simulations. Now, simulations are stochastic modeling techniques, and I just mentioned one, the Monte Carlo approach. You can use a whole bunch of other types of simulations that they're out there available. The Monte Carlo has been tried and true, and that's the only reason I use it most often. Now, most services use combination strategies and mixed plans. Controlling the cost of labor is a critical aspect of anybody's work environment. So accurate scheduling of labor hours to assure quick response to customer demands is imperative to reduce costs. An on-call labor resource to cover unexpected demand, if you can have that available, would be a plus. Flexibility of individual worker skills is also a plus. It requires a lot of training. Flexibility in rate of output of or hours of work is also a plus. So let's look at 5 service scenarios. In a restaurant, you would use a smoothing the production process type, or determining the optimum workforce size for that particular period of time. So if you're open, let's say 24 hours, then you'd have to look at what is the smoothing of the production process, whereby you have a breakfast, a lunch, and a dinner. And you smooth the production process to ensure that you have to, to determine the optimal workforce for the various shifts. In hospitals, you're responding to patient demand. Sometimes you have a large patient demand, and sometimes you have minimal to none. One good example would be in Miami-Dade County in South Florida. You would have Jackson Memorial Hospital. That's our major hospital that is publicly managed. We know that on Friday, sometimes Thursday evenings, but we do know that Friday and Saturday evenings are the heavy evenings in the trauma center. So that's how it's managed. They put a lot of the doctors that are skilled and that actually have had plenty of time in the operations and in trauma centers. That's when they go. That's at the time that they're in operations at that nighttime. Very few come in during the day. Nighttime is the peak. Right. The rest of the week, it's routine types of emergencies. National chains of small service firms, another of the 5 scenario, these national chains of small service firms do planning at the national level and then at the local level. Then there's the miscellaneous services, and they plan for human resource requirements and management demand. And in the airline industry is another example. This is an extremely complex planning problem for them. They have to think of number of flights that they have to set up, number of passengers on all flights, air and ground personnel at each hub and airport for adequacy and timeliness, allocation of seats, to fare classes. Now, let us talk about the material requirements planning, which is also known as MRP and ERP. By the way, ERP is Enterprise Resource Planning. So, dependent demand. Let's talk about that now. So for any product for which a schedule can be established, dependent demand techniques should be used. Benefits of an MRP. All right, it's A, better response to customer orders, faster response to market changes, it improved utilization of facilities and labor, reduced inventory levels. Now, the demand for one item is related to the demand for another item. Given a quantity for the end item, the demand for all parts and components can be calculated. In general, used whenever a schedule can be established for an item. MRP is the common technique. So think about that. If you have an end item, all the components that feed or that create that end item, if you know that you're going to have a demand of 10, you need to go ahead and make sure that all the subcomponents of that one you have enough, or you have production for enough to do the 10. That's what that's trying to tell you. That's why it's the most common technique. Now, some of the dependent inventory model requirements are effective use of dependent demand inventory models requiring the following: a master production schedule. In fact, this particular segment that I'm about to talk is very important. So if you want to pause and get a piece of paper and pen or computer up and get ready to type away, that's fine. You can also find it in the book because it's in your textbook. But these 5 components are very important in dependent demand inventory models. They require master production schedule, specifications or bill of materials, inventory availability, purchase orders outstanding, and lead times. Now, the Master Production Schedule, also known as the MPS, specifies what's to be made and when. It's a schedule. Must be in accordance with the aggregate production plan. Inputs from financial plans, customer demand, engineering, labor availability, inventory fluctuations, and supplier performance are an integral part. As the process moves from the planning to the execution phase, each step must be tested for feasibility. Master production schedules is established in terms of specific products. It disaggregates the aggregate plan. Schedule must be followed for a reasonable length of time. The MPS is quite often fixed or frozen in the near-term part of the plan. If you try to change it, that would be a change order, and it costs a lot of money. The MPS is a rolling schedule. The MPS is also a statement of what is to be produced, not a forecast of demand. So when we look at the planning process itself, the production capacity inventory, the marketing customer demand, and the finance or cash flow feed in to the sales and operations planning to generate an aggregate plan. But they're not the only three that feed into the sales and operations planning to generate this aggregate plan. So does the supply chain procurement suppliers performance and the human resource staff planning. All of these put together from the sales and operations planning of generating the aggregate plan, the master production schedule is produced. Now let's talk about this master production schedule. It can be expressed in any of the following terms: a customer order in a job shop, which is a make-to-order company; modules in a repetitive assemble-to-order or forecast company; an end item in a continuous stock-to-forecast company. Part of the component also is a bills of materials. Remember those 5 terms that we spoke about previously. Bills of materials, a list of the components, ingredients, and materials needed to make a product. You see that when you buy electronic equipment, you see the schematics of it. It tells you what it looks like inside. Some of us don't understand what it says, but I'm sure electrical engineers know exactly what it means. It provides product structure. Items above given levels are called parents, and items below the given level are called components or children. Bills of material can have modular bills. These modules are not final products, but components that can be assembled into multiple end items. Can significantly simplify planning and scheduling. Modules can include like computer systems. You would have a chip, and you could put the chip in any of the computers that you're creating because it's a processor. So, using the processor, you can make different types of computer. Modular. It can significantly simplify the planning and schedule because that chip could be used for almost any other computers. Cars use this too. Some of the models in cars, you can see sometimes the headlights are the same for different models, and you can go ahead and have a batch stock for various cars instead of having each one to be independently different. Consequently, you're reducing your actual labor cost and fixed cost of that production of the light. Planning bills, also known are called pseudo or super bills, created to assign an artificial parent to the BOM, bills of material. Whenever you hear BOM, B-O-M, that's the acronym for bills of material. Now, these BOMs are used to group sub-assemblies to reduce the number of items planned and scheduled. It's used to create standard kits for production. Phantom bills describe sub-assemblies that exist only temporarily, are part of another assembly and never go into inventory. Low-level coding are items, these are items that are coded at the lowest level at which it occurs. For the building of materials, BOMs, these are processed one level at a time. Now, accurate inventory records are absolutely required for MRP or any dependent demand system to operate correctly. MRP systems require more than 99% accuracy. Now, let's look at purchase order outstanding. A byproduct of a well-managed purchasing and inventory control department is the purchase order outstanding. Outstanding purchase orders must be accurately reflected, and they must show quantities and scheduled receipts. Lead times. Lead time required for purchase, production, or assemble of an item. For the production, the sum of the move, the setup, and the assembly or run times. That's what the lead time is. For purchase items, it's the time between the recognition of the need for that product and when it's available for production. Now, I want you to look at when you have a chance, pause this tape, you're not listening, and go to your textbook and look up figure 14-6. That is the MRP planning sheet. Take a moment to look at it and then come right back. For those of you that actually paused, looked at it and came back, welcome back. For all the others, thank you for waiting for the small pause. If you look at the MR planning sheet, you'll see that this one particular in the book is very simplistic. MRP planning sheets are usually lengthy, complex. The ones that I deal with are also color coded. You can do all sorts of that. The color code helps me understand priorities. But in this particular case, it's one that has the lot size, lead time, on hand, and on and on and on. You fill these out, and you're now doing the planning sheet. Fill, the gross requirements, the scheduled receipts, the projected on hand, and on and on and on. You fill all this out. This MRP planning sheet is very helpful because it allows you to go ahead and program what you actually have to produce. One of the things you're looking at the production schedule also is, thinking of safety stock. Now, safety stock is you would think it's an easy topic, but it really isn't. Safety stock is in the bill of materials. You need to go ahead and look at the inventory records. Your purchases and production quantities may not be perfect, so you need a safety stock sometimes. So when you need safety stock, when you do not have confidence that your bill of materials and your inventory records, your purchase and production quantities are not accurate. Consideration of safety stock may be prudent in that case, but you got to understand, safety stock should be minimized and ultimately eliminated because it's going to cost you money. You have stock. That's, if you have stock, that means you have holding costs. Safety stock is typically built into projects on hand inventory, projected on hand inventory. Now let's look at MRP management. Some of the dynamics in the MRP include the facilitation of replanning when changes occur. You have to be cognizant of the fact that the environment is fluid and changes do occur frequently. So you have to facilitate for this. System nervousness can result from too many changes. So try to keep changes at minimal. Time fences put limits on replanning. Once you hit that fence, you can't change it. And then pegging links each item to its parent, allowing effective analysis of changes. This can easily be done. The pegging can easily be done now with software systems. MRP limitations include that it does not detail scheduling. It plans. It works best in product-focused, repetitive environments. Requires fixed lead time and infinite size time buckets. Let's look at some lot sizing techniques. There's a term called lot for lot. And this is a technique orders just what is required for production based on net requirements. It may not always be feasible. And if the setup costs are high, lot for lot can be expensive. There's one that we in the MBA world know very much, and that's called the economic order quotient, EOQ. The EOQ expects a known constant demand, and MRP systems often deal with unknown and variables demand. But for planning purposes, you have to use something. So we use the EOQ. Remember, It expects a known constant demand. Now the periodic order quantity, or POQ, order quantity needed for a predetermined time period, such as an interval, which is equal to the interval type is equal to the economic order quotient divided by the average demand per period. Order quantities are set to cover the intervals. Order quantity recalculated at the time of the order is released. So every time you release an order, you have a new period, new EOQ, a new POQ. There is no extra inventory allotted. Dynamic lot sizing techniques include balanced lot size and setup costs. It's part period balancing, so it's least total cost. It's least unit cost and least period cost. Dynamic programming approach include the Wagner-Whiting approach. So let's sum up lot sizing. In theory, lot sizes should be recomputed whenever there's a lot size or order quantity change. In practice, this results in system nervousness and instability because there's always changes. And lot for lot should be used when low-cost setups can be achieved. Lot sizes can be modified to allow for scrap, process constraints, and purchase lots. Use lot sizing with care, as it can cause considerable distortion of requirements at lower levels of the BOM. When setup costs are significant and demand is reasonably smooth, the POQ or the EOQ should give reasonable results. Now, there are extensions of MRP, such as MRP2, closed-looped MRP, and capacity planning. MRP2 are known for requirement data can be enriched by other resources. Generally, this MRP2, or Materials Resource Planning, have outputs that can include scrap, packaging waste, effluents, carbon emissions, etc. And this data is used by purchasing, production scheduling, capacity planning, inventory, warehouse managers to know what's going on and at the same time forecast. Feedback for the MRP system is important. So every time the MRP itself is on the move or is cycling, we need to reassess. Load reports show resource requirements for work centers. So we look at the reassessments through looking at the load reports and seeing how we're doing with those with the actual reports. The reports are going to tell us how things are. Work can be moved between time periods of work centers to smooth the load or bring it within capacity. Now, there's some smoothing techniques or tactics that we can use. There's overlapping, which sends part of the work to following operations before the entire lot is completed. It reduces lead time. There's the operation splitting. These sends the lot to two different machines for the same operation. Shorter throughput time, but increased setup costs. And then there's the order or lot splitting, which is breaking up the orders into smaller lots and running part earlier or later in the schedule. Services and MRP, or MRP and services. Some services or service items are directly linked to demand for other services. These can be treated as dependent demand services or items, like restaurants, hotels, and hospitals. Distribution resources planning, or DRP, is using dependent demand techniques throughout the entire supply chain. Expected demand of sales forecasts become gross requirements. All other levels are computed. The distribution resource planning pulls inventory through the system. So it's a pull, not a push. Small and frequent replenishments. Now let's talk about lean operations. Lean operations supply the customer with exactly what the customer wants when the customer wants it without waste through a continuous improvement process. Lean operations are driven by pulling customer orders. In lean operations, we have topics like just in time. This focuses on continuous force problem solving. We also have the TPS, or the Toyota Production System, which emphasizes continuous improvements, you respect people, and standard work practices in an assembly line environment. Lean operations encompasses both the GIT and TIPS, TPS. It sustains competitive advantage and increases return to stakeholders. There are three fundamental issues with lean operations. It eliminates waste, removes variability, and improves throughput. Let's talk a little bit about eliminate waste. Waste is anything that does not add value to the customer's point of view. Storage, inspection, delays, waiting in queues, and defective products do not add value and are 100% waste. Now there are 7 topics in ONO's 7 wastes, and these are overproduction, queues, transportation, inventory, motion, overprocessing, and defective products. In eliminating waste, we're looking at other resources such as energy, water, and air, which are often wasted. When you're on idle mode, you're wasting all of those. Efficient, sustainable production minimizes inputs and reduces waste. And traditional housekeepings have expanded to the 5 S's. So you ask, what are the 5 S's? Well, sort, segregate. When in doubt, throw it out. That's what that one does. Simplify and straighten. These are methods analysis tools. Shine and sweep. Clean daily. Standardize. Remove variations from processes. And sustain self-discipline. Review work and recognize process. 2 additional S's may include safety, which is built in good practice, and support maintenance, which is reduced variability and unplanned downtime. Now, one of the key components is to remove variability. So what is variability? Well, it is any deviation from the optimum process. Lean systems requires managers to reduce variabilities caused by both internal and external factors. Inventory hides variability. Less variability results in less waste. Sources of variability include poor processes resulting in improper quantities, late or non-conforming units, inadequate maintenance, unknown and changing customer demands, incomplete or inaccurate drawings, specifications, or BOMs, bill of materials. Both the just-in-time and inventory reduction are effective tools in identifying causes of variability. So how do we improve throughput? Well, this is done through the rate at which, throughput, that is, the rate at which units move through a process. The time between the arrival of raw material and the shipping of the finished product or finished order is called manufacturing cycle time. And a pull system increases throughput. Have you noticed the trend that almost in all 3 of these, the pull system is used? By pulling material in small lots, inventory cushions are removed, exposing problems and emphasizing continual improvement. The manufacturing cycle time is reduced. Push systems dump orders on the downstream station regardless of the need, which is one of the reasons why pull is so important. Let's talk a little bit about lean and just-in-time. These are powerful strategies for improving operations. Materials arrive when they are needed, only when they're needed, and you don't keep any stock to include safety stock. Identifying problems and driving out waste reduces costs invariably and improves throughput. It requires a meaningful buyer-supplier relationship. Very important to have that. Why? Because a supplier partnership exists when a supplier and purchaser work together to remove waste and drive down costs. 4 goals of supplier partnerships include removal of unnecessary activities, removal of in-plant inventory, removal of in-transit inventory, and improved quality and reliability. Some concerns of suppliers include diversification. It ties to only one customer, increasing the risk. Scheduling. don't believe customers can create a smooth schedule. Lead time. Short lead times mean engineering or specification changes can create a problem. Quality. Limited by capital budgets, processes, and technology. And lot sizes are small. Lot sizes may transfer costs to the supplier. Let's look at distance reduction. Large lots and long production lines with single purpose machineries are being replaced by smaller, more flexible cells. Often this U-shaped line for shorter paths and improved communication. So imagine you have a normal and standard production line. It's exactly that, a line. But in the new U-shape, it's actually a U. And then one person to speak to another doesn't have to go all the way down the line. They can just go across and talk to the person. Often using group technology concepts to do this U-shaped, distance reduction type of thing. We would like to have increased flexibility. So cells designed to be rearranged as volume or design changes. Applicable in office environments as well as production settings. Facilitates both product and process improvements. Now the impact on employees include that they may be cross-trained for flexibility and efficiency. We do that now. Improved communications facilitate the passing on of important information about the process, such as a poke yoke functions can help. With little or no inventory buffer, getting it right the first time is critical. Let's speak a little bit about reduced space inventory. With reduced space, inventory must be very small. Plus, it lowers your cost, your fixed cost of the space. Units are always moving because there is no storage. In lean inventory, the inventory is at the minimum level necessary to keep operations running. Lean inventory tactics include using a pull system to remove inventory, reduce lot sizes, develop just-in-time delivery systems with suppliers, deliver directly to point of use, perform to schedule, reduce setup time, and use group technology. When we reduce inventory, we uncover the various rots that are there. The problems are exposed. Ultimately, there will be virtually no inventory and no problems. So when you eliminate inventory, there is no problem there, unless, of course, you don't trust the system, then you need that safety stock. Now, the term Shingo says inventory is evil. In ideal situations, when we look at reducing lot sizes, we would like to have lot sizes of one pulled from one process to the next. This is often not feasible. We can use the EOQ analysis to calculate desired setup time. And two key changes necessary include improved material handling and reduced setup time. I would recommend to you that you go to your textbook and look up the EOQ formula and become very much familiar with it. You will be using it quite a bit in your career. Now, in reducing setup costs, you have to understand that high setup costs encourages large lot sizes, so the smaller the lot sizes, the less the setup costs. Reducing setup costs also reduces the lot size, reduces average inventory. And consequently, setup time can be reduced through preparation prior to shutdown and changeover. Lean scheduling. Schedules must be communicated inside and outside the organization. Level schedules do the following: process frequent small batches, and freezing the schedule helps stability. Now, let's talk a little bit about Kanban. Kanban is K-A-N-B-A-N. Kanban signals the use in pulled system. Now, lean scheduling tactics include making level schedules, using Kanbans, communicating schedules to suppliers, freezing parts of the schedule, perform to the schedule, seek one piece make and one piece move, eliminate waste and produce in small lots, make each operation produce a perfect part. Level schedules process frequent small batches rather than a few large batches. Makes and moves lot sizes so this level schedule is economical, and freezing the schedule closest to the due date can improve performance. Kanban, in case you're wondering, is the Japanese word for a card. The card is an authorization for the next container of materials to be produced. A sequence of Kanbans pull materials through the process. Many different sorts of signals are used, but the system is still called a Kanban. When there's a virtual Kanban, the user removes a standard size container of parts from a small storage area as shown in your textbook on figure 16.8. The signal of the storage area is seen by the producing department as authorization to replenish the using department or storage area, because there's an optimum lot size. The producing department may make several containers at a time. When the producer and user are not in visual contact, a card can be used. Otherwise, a light or flash or empty spot on the floor may be adequate. Usually, each card controls a specific quantity of parts, although multiple card systems may be used if there are several components or if the lot size is different from the move size. Kanban cards provide a direct control and limit on the amount of work in process between cells. A complicating factor in manufacturing firm is the time needed for actual manufacturing or production to take place. So it's important to understand that the Kanban cards are needed when you need to know the lead time needed to produce a container of parts. Need to know the amount of safety stock also needed. So in this particular case, if we do a formula, simple algebraic formula, in order to find out the number of Kanbans or containers, then we need to go ahead and identify the demand during the lead time, and then you add safety stock and divide that by the size of the container. That gives you the number of Kanbans or containers that you need. Now, the advantages of Kanban include small containers, require tight schedules, smooth operations, and little variability. Shortages create an immediate impact. Places emphasis on meeting schedule, reducing lead time, and setting up an economic materials handling. Standardized containers reduce weight, disposal costs, and wasted space and labor. Now, when we speak about lean quality, there's a strong relationship here. Lean cuts the cost of obtaining goods quality because lean exposes poor quality. Because lead times are shorter, quality problems are exposed sooner. And better quality means fewer buffers and allows simpler lean systems to be used. Lean quality tactics include the use of statistical process control, empower employees, build fail-safe methods like Poka-Yoka and checklists, expose pure quality with small lots, or poor quality with small lots, provide immediate feedback. Let's speak a little bit about the Toyota production system. It stands for continuous improvements. You build an organizational culture and value system that stresses improvements of all the process. This is known as Kaizen. Part of everyone's job, Kaizen that is, which is total improvement, continuous. Respect for people. People are treated as knowledge workers, engage mental and physical capabilities, empower employees. Processes and standard work practice include work shall be completely specified as to content, sequence, timing, and outcome. Internal and external customer-supplier connections are direct. Material and service flows must be simple and directly linked to the people and machineries involved. And process improvements must be made in accordance with a scientific method at the lowest possible level of the organization. Processes and standard work practices include stopping production because of a defect called jidoka. Dual focus, education and training of employees, and responsiveness of the system to the problems. The result is continuous improvement. In lean operations, it is important that understanding the customer and their expectation is identified and followed. Functional areas communicate and collaborate to make sure customers' expectations are met. Implement the tools of lean throughout the organization. Transitioning to a lean system is difficult. You got to build a culture of continuous improvement. It's going to fail. Senior management must be bought in. Open communications is important. Demonstrated respect for people is key. And Gemba walks, also we used to call that management walking about, is to see work being performed. Lean systems tend to have the following attributes: respect and develop employees, empower the employees, develop work flexibility, develop collaborative partnerships with suppliers, and eliminate waste by performing only value-added activities. Two sides of the same coin. You maximize resource use and economic efficiency, you focus on issues outside of the immediate firm, and you drive out waste. This is the common ground. The lean techniques are used in manufacturing and also used in services. So you include suppliers, layouts, inventory, and scheduling. All in all, the complete scenario that we have just painted today is that we have to make sure that we understand the aggregate planning and sales and operations planning and how to be a lean planning process system. Thank you for visiting us today, and hope to see you next week.